Hi guys, welcome back to section. Let's get started.
Cool. So at the end of the cs50 lecture last year, this following question was posed.
This is known as the birthday problem. It's a really famous problem in probability theory. You may have seen it if you've taken a stat class. Before we begin, does anyone know the answer to the birthday problem? Like, let's say we've got 50 people in a room. What's the probability of getting a so-called birthday match? Yeah, Quincy. Yup, that's right. In fact, it's a lot higher than 50%. It comes out to about 97% probability if you do the calculations. So there is a formula, but oftentimes the formula can be really messy to work with, and sometimes the formula doesn't even exist. In those cases, we can use programs to generate lots of data and then analyze them to give us a good model of what we're trying to predict. So in today's section, what we'll be doing is writing a program that can do data simulation for the birthday problem and give us an estimate of the probability we're trying to find. Before we dive right into the code, though, it's a good idea to think about our design. And in data simulation, we break it up into two parts.
Step 1 is to generate the data, and step 2 is to analyze the data. So in the real world, we'd go out and we'd gather a random group of 50 people and ask every person in the group for his or her birthday. And then we'd see if at least 2 birthdays matched up. If so, we'd count the group as a success. And then we'd repeat this process for many groups of 50 people just to increase the accuracy of our prediction. After that, we can move on to the next step and analyze the data. To get the probability of a group having at least 1 birthday match, or the probability of a success, we simply divide the number of successes by the total number of trials, or groups in this case.
Okay, and voila, the answer that we get will be the predicted probability for our version of the birthday problem. Does anyone have any questions about this background info? Okay, sounds great. So let's begin. Does anyone have any idea about how to begin? Yeah, Ham. Okay, so what type should they be?
Okay, that sounds good. So we will start out with 0 successes. And as for the trials, how many should we perform?
Exactly. More trials will give us a more accurate prediction, but a bajillion of them will make our program too slow. So does anyone want to call out a number? Okay, so we'll have to increment successes or update it based on the data we generate. But how do we generate that data according to step 1? Okay, well let's look back at the slide and break things down step by step. First things first, we're going to need a way of generating 50 random birthdays. Does anyone have an idea about how we could do that? Well, that's a great idea, Fluffy. Definitely C does have a random number generator. And if you pull up the documentation, you'll see that the function returns a number between 0 and some really large number, certainly over 9,000. But we come into a problem here, because how many possible birthdays can we account for? Right. So how do we make sure that the output is a number only between 1 and 365, or say 0 and 364? Okay, so this means we'll have to wrap it around. So 365 becomes 0, 366 becomes 1. You got it, Poe. That's exactly it.
So to use the rand function, we're going to include 2 additional libraries. The first library that we're going to include is the standard library, where the prototype for rand resides. And the next library that we're going to include is called the time library. And we're going to include this so that we can set the seed according to the current time, just so that every time we run this program, we'll get different random numbers. So in order to set the seed, we use a statement like this: srand time null. And then we can use the rand function to get our random integer. So we can store that in an int called day, and we'll just call the function rand. And the percent sign here is the mod symbol, and we'll do 365. That way, all of the random numbers we generate are going to be between 0 and 364 inclusive.
All right, cool. So now we're ready to write the loop that generates the random numbers. Do you guys prefer a for loop or a while loop?
Okay, so we're going to generate a random birthday 50 times. So we start at 0, we go up to 50. Now, another design optimization that we can make at this point is to replace all of these magic numbers like 50 and 365 with constants defined at the beginning of our code. Now, why might this be a good idea?
That's definitely one advantage, especially if we're using these values at multiple places in our code. Any other reasons? Definitely. Anyone else who looks at your code might not understand why you chose to use the values that you used. Declaring them as constants would make your code a lot easier to understand.
Okay, so at the top, let's define trial size as an int to be 50, the size of our trial, and let's define the number of possibilities, the number of possible birthdays, to be 365. And then let's edit that in the code below. So trial size and num days.
So what do we do with these random birthdays? That's definitely a possibility, especially because we know the size is fixed at 50. So we'd create an array of size, trial size, store all the random numbers accordingly, and at the end we'd search the array of numbers for any birthdays that came up more than once. Searching for repetitions, though, might take a bit of code. We might have to sort the array and then see whether adjacent numbers were equal. Totally doable, but I think there's another way that can work with each birthday, and it takes less effort to write, and also isn't restricted by the size of our trial. Does anyone have an idea? Here's a hint. We do make use of the fact that there are only 365 possible birthdays. Alright, good start. And what's going to be stored in this array? Okay, the only thing we care about with each incoming birthday is whether that birthday appeared before in our trial. If it did, then our trial's a success. So what data type would be really helpful here? Excellent, Poe. Yeah, we can have a bool array that tells us whether a birthday has been generated before.
Okay, so first make sure to include the standard Boolean library, and then after that we can create our bool array. Let's call it bdays and declare it with our constant, num bdays. So what should all of the initial values be?
Exactly. No values have appeared before the trial begins.
Alright, so let's initialize the entire array to false.
This 0 in brackets is called the universal 0 initializer, which initializes pretty much any data type in C to its 0 or null equivalent. So this is a neat way to initialize all the elements in our Boolean array to false. Okay, so let's go back to our loop. After we generate the random birthday, what do we do?
Okay, great. So we can put that if condition right here. If bdays bday is already set to true, then what does that mean? Well, that means we've got a success, so we can increment successes by 1. Sorry there. And you know what else that means? We've definitely got a birthday match, so we don't even need to bother with the rest of the trial. No matter what, it's definitely a success at this point, so we can even break out of the loop.
Cool, so what do we do if the birthday hasn't appeared yet? Else what?
Yup, you got it. So else, if it's not true yet, then for future reference, we're going to change that day to true.
So we've generated one trial of data. Now we've got to generate oodles more of them, specifically 1,000 trials total. How do we do that? Yup, and where should this for loop go?
Yeah, that's exactly right. So we'll put everything in this for loop inside of an outer for loop. And what will this outer for loop go until? Yep, trials, j++, and then we'll put everything from the inner for loop inside this outer for loop.
Alright, so we're almost ready to go. We've generated our data, and now we have to analyze our data. How do we get our predicted probability? Shamu, would you like to give it a try?
Yep, that's exactly right, Shamu. So let's print that out using a printf statement. We'll say our prediction is, with the floating type, make sure that you cast appropriately, and finally we'll divide successes by trials.
Okay, so we've got the data generation and analysis going, and we're pretty much done here. Let's see what happens when we run it.
And for the moment of truth, right, we're compiling, and yeah, we've come across some errors. Alright, it looks like the first error comes from the compiler not knowing what string is. Right, so we can fix this by either including the cs50 library, or I think this might be the simplest option, because we don't really use strings in this program, just leaving the parameter as void. The second error seems to be coming from the fact that the compiler doesn't like using a variable like numBdays to define the size of an array. So I think what we will do here is copy the format of our pset3, the scramble program, and put all of these constants as definitions, or define preprocessor directives. Okay, so this is the code with the correct define statements. Then we've also made the corrections in the lower code here. And let's see what happens when we push play. Alright, building. Oh, it compiled correctly. But what have we here?
Strange. It runs, but the prediction is 1. So 100% of all groups have a birthday match. That clearly shouldn't be the case. So what's going on here? In particular, what's going on with our trial bdays array? You got it, Poe. Our array will be full of the true values from previous trials with no way to reset them. Every trial has to begin with a fresh, clean array of all falses, just like we did for the first trial. Does that make sense to everybody? Okie dokie then. Where can we add some code to fix this? Exactly. Now we can use a good old for loop to set every element to false, or we can make use of a handy C function called memset. You can find more details in the C reference page, but the basic parameters are as follows.
First, make sure to include string.h at the top, and then after that, you can simply type memset. Then you would type the array, the value that you want to set every member of the array to, followed by the size of the array, determined by the aptly named size of function.
Alright, let's run this program and see the numbers we get.
Alright, so after running the program a few times, some results that we get are 96.9%, 97.0%, and 97.6%. So what does everyone think of these results?
It does, doesn't it? In fact, the result you get from doing the probability calculations is 97.0%, which seems kind of crazy given that there are only 50 people in a group and 365 birthdays to choose from. That's why the birthday problem is sometimes called the birthday paradox. As counterintuitive as the result is, our prediction came really, really close to the theoretical value. And this just goes to show how powerful computers can be at simulating data and how accurately those simulations can make predictions about the real world at large. We can use computer simulations to describe complex systems with robust models, even when those models in theory don't exist. In the end, though, it all comes down to generating data and then analyzing that data. So the birthday problem we modeled in today's section has the fundamentals of data simulation, but it's just a starting point for some of the really crazy awesome stuff out there. Okay, so that's more than all the time we have for a section this week. Let me know if you have any questions or comments. Otherwise, see you all next week.